Can you see my screen and can you hear me as well?
Yep.
Yes, okay, thank you. So hi everyone and welcome to the afternoon session of our second day of Kickstart. In this session, we will give introduction to the HCC Open On-Demand portals. My name is Natasha and I'm research scientist at the Holland Computing Center. With us here today, we have other HCC staff as well to help with any questions or issues during the session. If you have any questions, please put them in chat. If you have any issues, please put a red Zoom reaction and someone from our staff will assist you. This session is recorded, as Colin said, but we will edit all the names and questions during the session, so please do not hesitate to ask anything that is related to the session. So what is Open On Demand? Open On Demand is a platform that gives access to HPC resources via web browser. Open On Demand is NSF-funded, open source, high-performance computing project that is developed and maintained by the Ohio Supercomputing Center. Open On Demand is widely used across many high-performance computing centers and organizations across the world, such as NVIDIA and Harvard, Stanford, and many other universities. We have had Open On Demand for 2 years now, and it's a wonderful tool that gives web access to our resources without requiring familiarity with the command line, which sometimes can be scary for researchers that are new to cluster environment. Our Open On Demand portals are widely used in classes, research, and outreach activities, such as the Kickstart. Open On Demand requires zero installation from the researchers. It is completely browser-based, and it only requires active internet connection, where you put the URL and you log in with the HCC credentials in order to access the portals. As I mentioned, Open On Demand is browser-based and has a nice graphical interface that is very easy to use. Besides the GUI interface, Open On Demand supports multiple features I will go over in the next slide. So Open On Demand is fully web browser based and provides full access to our clusters. So everything we've done so for utilizing our clusters can be done via the Open On Demand portal. Users can navigate the different file systems we have. They can write and submit jobs, access our documentation page, reset their HCC password if needed, and much more. Open On Demand provides file management options where researchers can create and edit files. They can copy files from their local computer to the clusters and vice versa. If the files are very large, then we recommend using Globus that was introduced yesterday, but for smaller files, the Open On Demand file management is very convenient. As part of the Open On Demand portal, we have examples of submit scripts for various widely used software tools on our clusters. Our researchers can copy these existing templates, they can modify them and submit jobs and monitor the jobs as they run. One of the main advantages of the Open On Demand portal is the capability to run graphical user interface applications. The traditional Linux and high-performance systems are not intended for running graphical applications. But we are aware that sometimes some packages only have graphical interface and researchers need these tools to do their research. And this is where the Open On Demand portal comes in. So we provide interactive desktop as well as various graphical applications such as RStudio, MATLAB, COMSOL, FreeServer, and many more. We constantly update this list and we add new applications as our researchers request them. Besides interactive apps, we also have a JupyterLab notebook that supports multiple kernels. Some of them are shown in the figure here. Besides the system-wide kernels such as Python and R and TensorFlow and Julia, MATLAB, Keras, we also have an option for researchers to create their custom kernels and use them via the JupyterLab notebook. And I have a link to the documentation page that explains that a bit later. Besides all of this, Open On Demand also has a shell access to the login node via the traditional Bash client interface. So during the rest of the session, we will explore some of these features hands-on. As you all know by now, we have two clusters, Crane and Swan, and each of these clusters has their own instance of the Open On-Demand portal. The URL to the Crane Open On-Demand portal is crane-ood.unl.edu, and for Swan is swan-ood.unl.edu. For the remaining of the session today, we will use Swan, but the setup and the steps are exactly the same for both clusters, so you can use either depending on your preference. As I mentioned, we have detailed documentation about Open On Demand, and that is what I will be following mostly during the remaining of the session. If you miss any of the steps, please don't be worried. You can check the documentation page. Okay, are there any questions before we proceed to the hands-on part of the session? No? Okay, great. So the first step will be to log into the Swan HCC Open On Demand portal. So for whoever wants to follow these exercises, we'll need a browser. So in the browser, we'll type Swan Open On Demand unl.edu. So this will ask you for HCC username and password. So please put your HCC username and password. I'm using a test username for the workshop today. And then we will be asked for the do a push, so click on send me a push and approve the request. And we're in. So this is how the Open On Demand portal looks like. This is the message we see when we log in on the ClusterSphere terminal, and there are multiple tabs here with different functions. I will go over in a bit. Here under help, we also have link to our documentation. You can check, and also if you want to change your HCC password, you can use this link as well. So let's check out what each of these tabs are. So the files. The file tab listed all the file systems you have access to on our clusters. So we can click the work file system. I don't have anything in my work directory on Swan right now, so that's why it's empty. If you have any files, you should be seeing any files here. So this is the location of my work directory on Swan. We can also access the home directory where I have more files, and the common directory as well. So I went back to the work directory. Let's try to create a text file now. So we can click on new file. We can name the file any way you want to name the file. I'll put mine Kickstart 2020 text. So we can see the file is created now. We can edit this file by clicking on the drop-down box here. And we're open text editor. So we can write something inside. I will do I am attending HCC Kickstart 2020, and then there is a button save here. So this means the file is saved, and we can, if you hit an extra tab open, we can close that. Now let's see the changes we did to the file. If we go to the drop down box again and go view, we will see the text we modified. Are there any questions regarding this part? Most of the features of the portal are self-explanatory. There are lots of buttons and options. So let's try to download this file to the local computer we are using. So if you just select the file, there is a download button here. And I just downloaded the file locally for myself, and you may get a pop-up on your browser, depends on how it's set. And then you log in with your HCC credentials. And we are under the Files tab into the work directory. So now if we have a file on our local computer we want to copy back, we want to copy to our clusters. We can go upload, browse files, this will show the files I have on the desktop, and I'll just copy a screenshot. You can copy any type of file you have, just so we can practice the process, and upload the file, and the file is already here. And this is on our work directory on Swan. So that's where we have the Kickstart text file and the screenshot I just copied. If there are no any questions or issues with this step, we can proceed to the next step, which is jobs. So the jobs tab, it gives options for submitting jobs as well as monitoring running jobs. So we can monitor our current running jobs, which there is none here for me because I'm not running anything on Swan right now. We can also see all the jobs that are currently running on the clusters by selecting the all jobs option. So we can see there are many jobs currently being run from different groups and researchers. So let's try to submit a job. So if we select the job composer option, I'll just cancel this. You can read this yourself after. So we do provide templates for various software packages that are commonly used on our clusters, and we can see a list of these submit files under the from template. So this is the list. So we have general job, Abacus, Blast, Comso, Fluent, Mathematica, R, Python, and many others. So let's try to submit one of the existing jobs. So for that, we can let's select Blast. Blast is a bioinformatics tool that performs alignment of nucleotide and protein sequences against the database. So when we select this already existing job, it tells us where it is, and it tells us all the files that are required for this job. So if we open the directory, this is a directory on our work directory on Swan that has the Blast job. So if we click on the file, we will see how the submit file looks like. As you will see, this is the submit file that was mentioned in one of the earlier sessions. We have the sbatch commands, and we also have the part that actually calls the tool we want to use and run it accordingly. So if I go, let's just run this job as it is. So we just select the currently existing template, go on create new job, and this will put the job in our queue, but the job is not submitted until we click on submit. So let's click on submit, and then we will see that the job is running. This will take a few minutes, so we can check the status of the job later. In the meantime, let's try to submit another job, but let's try to modify the parameters for this job. So we can go again from new job, from template. This will list the jobs we already have templates for. So let's select the Python job. So if we just create a new job, it will run as it is. But since we want to modify this job, we can just copy the template by clicking on copy template. This just tells us where the job is located. We can just click on save and move forward. So we will see now that the Python job is shown here as my templates. So now, since we want to modify this job, we can click on view files and modify the submit script. So python.submit is the submit script. I want to modify, so I click on edit. And I want to change the running time. So the default running time of this submit script is 10 minutes. Let's make it 3 minutes. So let's save. And then we can go back. Since we modified this template, we can click on my templates and create new job, and then submit. So yes, the session will be recorded, and you can watch it online as well. As I said, it's very self-explanatory portal, so it's mostly clicking on buttons and let the portal does the work for you. So we submitted 2 jobs. If we go back to the main page, it will go to job under active jobs. And then I want to see my running jobs. So if I click on my jobs, we will see the 2 jobs we just submitted. They will have a different username and account for you than me. So it will take a few minutes for these jobs to finish, so we can just let them run and we can proceed with the rest of the session. So the portal also allows a shell access to the cluster, and this is under the clusters tab, so cluster shell access. And this opens the terminal, the one that has been used in the previous sessions, and we get access to the login node. So you can either open the terminal via the computer as it was shown earlier, or you can use terminal from the Open On Demand portal. Let's see, the jobs are still running. So the next part of the Open On Demand portal is the interactive apps, and this is one of my favorite parts of Open On Demand. So the traditional Linux and high-performance systems, they're not intended for running graphical applications. There are ways how researchers can run graphical user applications, but they can be very slow, and then your computer needs to be on all the time and have active internet connection for this application to run. But we understand that sometimes some researchers need GUI applications to conduct their research, and Open On Demand allows running GUI applications on our clusters by using interactive desktop and the interactive apps themselves. So once the interactive desktop or apps are started, they run on our clusters for the time you have specified for these apps to run. And if you lose internet connection or close your browser, you can just log in again, and the desktop will be still running. So let's try and launch an interactive desktop. So when we click on the desktop from the interactive apps, there is a form here that allows you to select some of the resources we need to run the desktop. So we provide 2 types of desktop, Alma Linux and Ubuntu. Let's select Ubuntu. Then the next few fields allow us to select how many cores and how long we want to run the desktop and what is the RAM we needed. I need to mention here that we have limitations of these resources. So one can ask for maximum of 16 cores, maximum of 8 running, maximum of 8 hours running time, and maximum of 62 gigabytes. This is not the maximum of resources our clusters have. So the maximum runtime on our clusters is 7 days, and we do have nodes with few terabytes of RAM on our clusters. The Open On Demand portal is mostly used for educational purposes, and the portal itself does not support well high resources here. So we cannot just allow a request of 2 terabytes of RAM. Additionally, requesting more resources, it's gonna lead to long waiting queue times, and sometimes people may forget that they have the resources requested on the portal. So the purpose of the Open On Demand portal is educational for classes and also for researchers to get familiar to how to use our clusters. That's why the resources here are limited. If you need more than 62 gigabytes of RAM, or if you need more than 8 hours of running time, then I would suggest you to use the terminal and submit your job as a batch script. So now for the session, we can just select 1 core, 1 hour, 4 gigabytes of RAM is okay. We allow we allow researchers to choose their own partition here. That can be batch or GPU, or if they have a list partition can be specified here. So we can just use batch here, and then we can go to launch. So while we're waiting, the job is sitting in queue, and we requested 1 hour. So after the 1 hour expires, the job will be terminated. So we can go and launch desktop now. So this will open a desktop on your HCC account on Swan. By default, we're located on Home. But this is, so instead of using the terminal, we have desktop now. So we can open the terminal from the desktop. And I will just load the module MATLAB, because MATLAB has graphical interface, so you can see how it looks like. I loaded the module, and after I loaded the module, I will just execute it with MATLAB. And it will take a few seconds for it to start. So see, MATLAB has GUI and it's currently launching. So the interactive desktop is very useful for running graphical interface applications on our clusters. Any questions while we're waiting for the program to launch? Okay, so for any one of you that uses MATLAB, I assume you're familiar with this interface. So now you're actually using MATLAB on our clusters, and you're accessing the memory and the resources provided by our cluster. Okay, I will close this now so we can proceed. Once you're done with your session, you can just let the time expire. You can just go delete and delete the current session. So this is the desktop. Beside the desktop, we provide different graphical interface applications as well, such as COMSOL and MATLAB itself, and RStudio and others. And as our researchers need more apps, we add them to this list. So someone earlier mentioned about RStudio. So we do have RStudio server available as an app on our clusters. So let's try that one now. We can go to RStudio server. So here we have multiple versions of R we support, and as well as different variants depending on the type of research. For this purpose, we can just select R 4.2 and the basic variant. And same as before, like we need to specify the number of cores and hours and requested RAM. 1 core, 1 hour, and 2 gigabytes of RAM is enough for this session, but for your research, you may need to increase these numbers. And if these numbers are not sufficient, then you will need to use the batch submission system. So the normal queue, the batch, and we can go to launch. So same as before, we're waiting here while the scheduler finds nodes that fit our request. So okay, looks like our job has started. So to log into RStudio, here at the bottom, you will see username, which is your HCC username, and password. So we need this password to access the server. So just click to copy, and then go to log into RStudio server. So username is your HCC username. Password is the password you just copied. So you can just do paste or Control-V, and then click on sign in. And this will open RStudio server that runs on our clusters. If you need any additional libraries or packages, you can install them as part of this session. So let's see, I want to start the library ggplot2. So it says there is no package, so let's install this package. Install packages, GG. So same as you would use RStudio on your computer, that's how you would use RStudio on our clusters as well. Just this is run on the cluster itself. As I mentioned, we have multiple versions of RStudio. So currently we're using 4.2, and we are installing ggplot2 under the version 4.2. If you want another version, then so this package is available only the version under the version we're currently using. If you need another, if If you use another R version, then you will need to install the package again under that version. But once the package is installed, it is there every time you launch R 4.2 in this example. Okay, so we can see that the package is downloaded on our home directory on Swan. And now let's try to load the package. Yep, looks like that worked. So, so this is how you install packages, and then you can write your code as you would on the RStudio server you used. You can check the current directory. So I'm currently in my work directory, but we can set the working directory to a different path as well. And again, once we're done with the any of the apps, we can either wait for the time to expire, or we can just go ahead and delete the app. Any questions about the apps we support? No? Okay, let's go back to the jobs and see what happened to the jobs we submitted. Let's go to active jobs. Okay, so these are my jobs. It says completed. Okay, let's see. So if we click on the arrow here, it will tell us detailed information on the job that was run, the cluster, the job ID. The job ID is very useful for us to debug any issues you may encounter. So when you have any issues with the job you're running, you can send us an email and specify the job ID as well, and we can take a more detailed look at it. It tells us what's the output location on the cluster, and then we can just click on Open in File Manager to see the output files. Oh, sorry, this is the, I clicked the wrong job. These are both the desktop, my job, all jobs. Let me try to find the jobs. So these two jobs are the desktop and the RStudio server jobs we ran. The previous ones should be a bit lower, I guess. Okay, sorry about that. So if we go under the job composer, active jobs, they're here. So we go, so there are error and output files shown. Go to the error one. Okay, so this job was canceled due to time limit because we only specified 3 minutes of running time. And if we go under the last job 80 times. So we do have, so every job will produce output and error files, and we can look at these files just to make sure everything finished correctly. Okay, these are just some log files, and the output from BLAST is this total alignment file. So if we click on it, this looks correct, so we can see the output. So yeah, looks like one job finished correct and the other job was canceled because the runtime of 3 minutes we requested was exceeded. And you can find those under the jobs tab here. Okay, so let's go back to the interactive apps. Just close this. So another app I want to mention here is Jupyter Lab. So same as the other apps, we need to launch this app by requesting certain number of resources. The default ones here of 1 core, 1 hour, and 2 gigabytes of RAM is enough. As I said, if any of this is not enough for you, you can go as high as to 8 hours and 62 gigabytes of RAM. And if this is not enough, then you will submit your code as a batch job on the clusters. So let's launch this. While we're waiting, I'll just check the chat. Okay, so the session is being launched. We can go connect to Jupyter. Okay, so this is the notebook itself. We have multiple system-wide kernels, such as Python and Julia, different versions, MATLAB, R, TensorFlow, and our researchers can also create their custom environments here, and I have the link later to show you how to do that. So let's try the Python 3 kernel and Python 3.9. So let's start the Python 3.9 kernel. So this opens a Jupyter notebook. I know lots of you are familiar with using Jupyter notebooks on your local computers. So now this opens up Python based notebook, and we can type Python code to run. So I'll just do import numpy, and let's just print something. So every notebook is by default saved in your home directory. So even if the session is terminated, you can go back and reopen the notebook. You can also save the notebook with different name as well. Once you're done with the notebook itself, I would suggest you to shut down the notebook itself. Sometimes when multiple notebooks are running underneath, that can cause issues when you're trying to relaunch the notebook again. So whenever you're done with the code and the code is saved, you can just go shut down all and close all notebooks and terminate. Save it's okay, yeah, and terminate the session. Any other kernels you're interested in? We should look at. So lots of the machine learning and deep learning classes are using the Jupyter Lab on our clusters, and they use TensorFlow as a notebook, and they also create custom environments as well. So these are the main features of Open On-Demand. As I said, it's very nice way to access our clusters without using the terminal. You can submit jobs, you can monitor jobs, and especially the desktop and the interactive apps help a lot with the interfaces they have. Cell Ranger, no, that's a specific application. We do have documentation on how to run Cell Ranger on our clusters, and I think I've sent you the link. RStudio, I just covered the RStudio. Was it clear, or you need more information about it? Okay, so go back to, I mentioned the custom conda environments, which some of you may find useful. If you go back to the documentation page we have, hc.unl.edu, if you search for Anaconda. So there is a blurb here about using Anaconda environment in a Jupyter notebook. So if the system-wide kernels we have are not sufficient for you, and you may need Python but with some additional, more research-specific packages, what you can do is you can create a conda environment as it was mentioned before, and then once the conda environment is created, you can follow the instructions here to make your Conda environment to be visible from the Jupyter Lab notebooks. And then you can use Jupyter Lab. Thank you, Adam. So yeah, is there something you want to try on On-Demand in particular, or some feature you're interested or you think you will be using as part of your research? So this is the Open On-Demand portal for Swan. As I said, we have the exactly the same one on Crane. It's just you use Crane instead of Swan. I'm already logged in, so it remembers your session, and I'm already logged in. But they look exactly the same. Okay, let's see what else we can do. We can try some of the GUI applications we have here. So for some packages, we support multiple versions, and it's up to you to select the version you want. So this is Free Surfer. We have multiple versions. Let's pick the newest one. Again, we select the number of cores and hours and running in RAM. So we have multiple. I would say just use the normal queue. The short queue is for a faster throughput. The batch partition is what we use, and then launch. So it takes some time to get the requested resources, and if we request for 7 days of running time or like 1 terabyte of RAM, the job will be sitting in a queue for a while. So that's why for more intensive jobs, it's much better to use the command line and submit the jobs that way. Okay, let's launch Free Surfer. Okay, I'm not really familiar with this package, but I can just show you how the graphical interface how the graphical interface looks. So we can is it possible to request software? Yes, you can request additional plugins for MATLAB. You can use the software installation link and send us an email, and we'll be more than happy to install that toolbox as long as it's supported with the license the university has. That remembers set up across sessions. You mean I believe it should remember as long as the session is active, you can close the browser and open again. And yes, I believe so. I believe so. I know R does, so I assume MATLAB works the same way as well. You can save the session and then just relaunch it when you start. And you can, I did not mention that, but you can start multiple apps at the same time. They're all submitted as jobs to our cluster. Yes, to end the session, you can just close the browser. And as I said, you can, I closed the tab for the Free Surfer app, but the app is still running here because we requested 1 hour of running time. So you can just let this hour expire, or to be a nice user, you can just go delete and cancel the session. You can run multiple applications. So the Free Surfer is currently running, and if I relaunch it again, it will be exactly as I left it, so it remembers your current session. Let's try to launch MATLAB as well. We have multiple versions of MATLAB. Let's pick the newest one. Again, select number of course, running time, and requested RAM, and launch. Okay, so the free server app is still here, it's still running, and the MATLAB jobs just started running, and we can go to MATLAB. See, like unlike the interactive desktop where we needed to load a module and start MATLAB, the interactive apps, they already have everything set. So once you launch the app, the graphical interface shows right away. Yes, I believe, yes, the session should be saved. And all of these files are and sessions are saved on your work directory on the cluster you're using. So yeah, this is now MATLAB R2022A. And you can use it as you would use it on your clusters. Again, I can just close the tabs here, but to be nice and let someone else use the session, since I'm not using them, I can just delete, and this will remove them from your running queue. Any questions? If not about Open On Demand, just the application part in general, maybe.